Hello students, welcome to Spectra Education Academy. In this video, I am going to explain how the forces can be listed out when number of bodies are connected with the help of string or when number of bodies are in contact with each other. So the main heading of the main heading is connected bodies, and free body diagram. Free body diagram. So in short form, you can call it as FBD. Okay, so remember the first point, whenever bodies are in contact, so there are some rules. So first, what is free body diagram? Let us complete it. When several bodies are connected by strings, or you can say springs, surfaces of contact, then forces acting on the bodies are considered and sketched. On the body under the consideration by isolating it. So if number of forces are acting, so we make it distributed one by one. The diagram so formed is called free body diagram. So this is the first point. Now let us move to the second point. Second point is the reaction force. Also called normal reaction, which always acts perpendicular to the surface on which it is kept. For example, suppose let us say this is a surface. When body is placed on the surface, so its weight acts vertically downwards towards the center of the earth. Let us say mg is weight. Against weight, the reaction, you can call it as a normal reaction, but it acts perpendicular. So this is surface of contact. Perpendicular to surface of contact. You can call it as normal reaction. Suppose when body is on the inclined plane, how the normal reaction will be is, so this is the body. So here once again mg acts vertically downwards. Since the inclined plane is surface of contact, so perpendicular to surface of contact, there will be normal reaction. Then there will be a component of mg. You can call it as mg cos theta. Then another component will be parallel to inclined plane. It is mg sin theta. So this is how normal reaction acts on inclined plane and on the plane surface. Next point. When a block is connected to a spring and spring is stretched by a distance x, then force on the block is equal to kx. So which is opposite to stretching force. So and k is spring constant. Next, fourth point. A pulley changes the direction of force in a convenient direction. If pulley is light, and frictionless, and string passes over the pulley without any kinks, the tension acts either sides of the string is the same. Next point, while drawing free body diagram, we always take into account how many forces acting on the body, but we never take into account force by the body on the strings, or force on one body by the other. Sixth point, all quantities involved in writing the cause effect equation must have same units as that of force. Next point. The last point, sometimes we may require coordinate access for writing cause effect equation. For example, along x-axis, sigma of fx is equal to 0. It means all forces acting along x-axis will be equal to 0. Similarly, sigma of fy is equal to 0. Similarly, sigma of fz is equal to 0. Otherwise, we can also write sigma of fx is equal to max. Sigma of fy is equal to may. Sigma of fz is equal to maz. Students, in my next video, I'll continue with the examples of free body diagrams. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.